This video is on atomic structure. So atomic structure has to do with the structure of the atom. An atom is the smallest particle of an element that retains its identity in a chemical reactions. Atoms are tiny, and there's been lots of experiments done to help us understand the different parts of the atom and how they behave. The three different particles that are inside an atom are protons, neutrons, and electrons. These particles are called subatomic particles because they're smaller than the atom. First one we have is a proton. Symbol for a proton is a lowercase b with a plus sign. This is because a proton's charge is positive 1. Other one is a neutron with an n with a little 0 above it. The 0 represents the charge of 0. An electron is a lowercase e with a negative sign after it. This represents negative, that the charge is negative 1. The actual masses of protons, neutrons, and electrons are very, very small, times 10 to the negative 24. A proton and a neutron have the same mass of 1.6 times 10 to the negative 24 grams. An electron's mass is to the negative 28, so that's much, much smaller than a proton or a neutron. To help us understand these numbers, we make atomic mass units. These are relative weights based off of the fact that protons and neutrons are equal to each other, and electrons are extremely small. We say that a proton and a neutron have 1 AMU, or 1 atomic mass unit, and we say that an electron, because it's so small, it's basically 0. Their location in an atom: protons and neutrons are both found in the nucleus. Electrons are found outside of the nucleus. We find them on rings around the atom. So if we are to look at an atom, we have our nucleus in the middle with our protons and neutrons. Almost all the mass is here inside our nucleus. Here, our mass number is told to us by the number of protons plus our number of neutrons found here in my nucleus. Then we have rings around the nucleus. This is where electrons are. They circle the nucleus like planets circle the sun. We assume that electrons have no mass. So an atom has no charge. My number of protons in an atom, which is specific to the element, is equal to my number of electrons. Every atom has a mass number, and this is where all our mass is found in the nucleus. Here we see that our mass in our nucleus is made up of protons and neutrons, so protons plus neutrons in the nucleus make up our mass number. An atomic number is a number specific to the atom we have. Our atomic number is specific to the element and is also equal to the number of protons. If we look on our periodic table, we can see that we have our atomic number at the top, our symbol, our words, and then this is an average atomic mass. These are decimal points, whereas our mass number is a whole number. These are similar to our mass number, but they are different. So on the periodic table, what we can pull off for information is our atomic number, which is the number on top. Remember that the atomic number is also the number of protons. So here, if I'm looking at lithium, my atomic number of 3, that means that I have 3 protons. When we're looking at symbols of our elements, we can tell our audience what the mass number and the atomic number is along with our symbol. So when we write this, we're going to put our mass number on the top, our atomic number on the bottom, and then we'll write our symbol next to it. So let's work through an example. I'm told I have the symbol of 184 over 74W. My atomic number, I know from above, is equal to my number of protons. So I'm going to write the atomic number equals my number of protons. My mass number is equal to the number of protons plus my neutrons. My number of protons is equal to my atomic number. My number of electrons in atoms is equal to my number of protons. And my number of neutrons is my mass number minus my number of protons, because protons plus neutrons make my mass number. So let's work through the first example together. I have 18474W. When I write this, I put my mass number over my atomic number. So my mass number must be 184, and my atomic number must be 74. Atomic number is equal to my number of protons, so I can fill out my protons of 74. For atoms, my number of protons equals my number of electrons, so that's also 74. And then I need to figure out my neutrons. My number of neutrons is equal to my mass number minus my number of protons. So my mass number of 184 minus my atomic number of 74 gives me 110 neutrons. In my next example, I'm told my atomic number. I know my atomic number goes on the bottom, so I write 29. I also know my number of electrons, same as my protons, and I'm told my number of neutrons. I want to know my mass number. My mass number is my number of protons plus neutrons. Protons is equal to my atomic number, so I write 29. I want my mass number. My mass number is protons plus neutrons, so 29 plus 37 is 66. And then I need to figure out what my symbol is and my formula. So I look on for atomic number 29 on my periodic table. And when I do that, so I start at 1 and I go across until I find number 29. 29 is copper, Cu. So that means I have Cu as my symbol. And rewrite them as a capital letter first and a lowercase letter second. On our next example, I'm told my mass number, my number of protons, and number of electrons. My mass number I know goes on the top, so I put my mass number on the top. Protons is equal to atomic number, so I can write my atomic number of 8. And then I can look on my periodic table using atomic numbers to figure out what my element is. If I look on my periodic table, I find that element 8 is oxygen. So here I can write oxygen, and its atomic number is 8. And then I need my number of neutrons. Neutrons is mass number minus atomic number, so 16 minus 8 is 8.